welcome back to another episode of the Think Onward webinar series. Today I'm joined by Jesse Feisel.
We're basically going to run through how to get up and running with the Geophysical Foundation Model. So I know a lot of you might have attended our webinar at the end of last year where we talked about the Geophysical Foundation Model, or what I'm going to just refer to as the GFM. And you saw us work through this tutorial notebook, and it might have seemed like, wow, that was a lot. Like, how do you guys even get this up and running? So today we're going to just go step by step by step and show you how to get the get that tutorial notebook up and running. So with that being said, what I'm going to be working from today is the Geophysical Foundation Model GitHub repository that I just dropped. I don't know if everybody can see that in the chat or not.
I'll take care of it, Jesse. You can keep rolling.
Right on. So we'll work primarily off of the GitHub, and then we'll kind of go back and forth between the GitHub page and then also my terminal as needed. So if you're on a Mac machine, it's just a terminal. If you're on a Windows machine, you can use something like a Git window or PowerShell or whatever you're comfortable with. But those are kind of our two kind of prereqs of three prerequisites. So you have to have a GitHub account. You have to have a Hugging Face account just to access things. You should be somewhat comfortable with using a terminal, just so that you can kind of follow along. And then I think the last thing that I've got on my list is you should have Python installed on your machine as well. I'm not going to go into full in-depth how to install Python, just because we'd be sitting here waiting for everything to download and get running. So strongly recommend just, once you've got, if you don't have Python installed, you can kind of watch, follow along, take notes. And then once you get Python installed, at a later date, come back to the learn content on the platform. And that's where it's great. You can hit the pause button, get things installed, make sure you're cruising right along with us. This is that very first link that Clark shared. This is our Geophysical Foundation Model, or GFM, on GitHub. And so when you come to this repository, this is what you're going to see. So you'll see a bit of information, a bunch of different files in here. And really the thing that we're interested in down here is this README down here. So this README file is going to tell us everything that we need to know to get started with the GFM. So as you see up here at the top, we've got this table of contents. These links here, these will just take you to different portions of the README. So how to fork and clone the repository, getting started, running the model, contributing, some model details. If you're curious on architecture, some uses, training details, things like that. These are all in the table of contents, and that clicking on this will just take you directly to that section. So if I was interested in uses, I could click on that and it would take me down to the uses section, and I can kind of read, what is this thing? How do we use it? So with that, I'll come back up to the top. And so we'll go ahead and get started here with our how to fork and clone the repository. So this is kind of the big, this is the hardest part effectively. So once we get started, we want to fork the repository. So for those of you that haven't used version control in the past, this means we're just taking this repository and think of it as making your own copy of the repository. So rather than working on the main copy, you're effectively working on your own copy so that any changes you make are just yours to work on and play with as you want. So we are on the Geophysical Foundation Model repository page, so we're already there. And it says, click on the fork button located at the top right corner of the repository. So I'm going to scroll up. And I see this little fork button here. And so this says fork. If I hover over it, it says fork your own copy of ThinkOnward's Geophysical Foundation Model. So I want to fork it because that's what it told me to do. So I'm going to click this fork button. And now it's got a really good explanation. Just like I mentioned, a fork is a copy of a repository. So it allows you to freely experiment with any changes without changing anything. So think of it as like you can make your own copy and like do whatever you want. You can't hurt anything. You can't break anything. I always told folks that, making your own fork is like you can't hurt the original one. It's very tough. So I'll go ahead and create a new fork here. So I've got my GitHub here, and I'll just leave the name Geophysical Foundation Model. And I don't need to change anything else. And I'm just going to copy the main branch. So I'll leave that check mark there. And so I'll hit create fork down in the bottom right on this button. So I'll click on that and it'll tell me it's creating my own fork of this. Now I've got my own fork here. And so you can see that it's under my account. This is my little avatar here. And you can see that it's forked from, and this is the original one that it's forked from. Now on this page, we'll just keep working through. So step one, done. All right, so now we need to clone the forked repository. So cloning, for those that have not worked with Git in the past, cloning is, if forking is making a copy on GitHub, think of cloning as just making a copy on local machine. Or if you're working in SageMaker, cloud environment, it's making a copy to whatever machine you're working on. So forking, I've made my copy on GitHub. Now I want to clone it and make a copy to my, in this case, my local machine. So to do that, it says open a terminal or command prompt. So on a like a Linux-based device that, or like a Mac device, that would be a terminal. On Windows, you have a couple options. You can do like PowerShell, where things are slightly different. Or Git has a great shell you can use, download and use on Windows machines. I'm going to be using, I'm on a Mac, so I'll be using a terminal window. So this is what a terminal looks like. It comes up, there's nothing here. Tells me a little bit of information about where I'm at. So I'm in a folder called, or a directory called webinar, and mine's got some additional kind of bells and whistles that clean it up and make it a little bit shorter here. So that's what you'll see when it first pops up. Obviously my cursor is not going to do anything here, but if I type in things, I can type things in here. So this is where you'll add in terminal commands, is in this terminal. So what I'm going to do is, for step 2, it says clone the forked repository. So it says open a terminal or command prompt. We've done that. Cool. All right. So now we need to navigate to the directory where we want to store the cloned repository. So in my case, it was that directory that said webinar. So I don't need to move around anywhere. If I wanted to change it, there's a command that just changes the directory, which is cd, literally the word cd. You'll see that down here. So you can change directories as you will. So we're good on where I want to clone my repository. And so now it says run the following command to clone the forked repository, and remember to change the your username portion to your actual GitHub username. So this right here, your username, change this to your GitHub username. If you try this, unless there's a user out there with that string as their username, with this model, it's not gonna do anything. So I can copy this with this little button over here on the right. And so what this is doing, this is basically calling the git command. It's saying git, we want to clone, and then think of this as like this git at github.com, and then all this other stuff is, think of that kind of like it's almost like pointing at a website to an extent, just saying we want to clone this thing at this address on GitHub. So I've got this copied, and I can just paste this sucker in here. And so we've got git clone, git at github.com, and then remember we need to change this here. So we need to change my username. So for example, if I just said no user and I run that, it's going to say, hey, I don't know what you're talking about. I don't know what you're pointing me at, because it doesn't exist. So I need to make sure that that points at my username. So I'll re-pull up that last command. And to do that, I'm just going to press the arrow up key. That pulls up my last command. We'll come back in here and we'll just change this to my username here. And then if I hit enter, it'll say, okay, cool. So it counted what all is in that Git file and compressed them down, and then basically just downloaded them all. And so we've got them. Okay, cool. We've got it on my local machine. And so in the terminal, what we could say is we could list out what all is now in the directory with this ls command. And we can see, okay, so we see there's a directory inside of this webinar directory. And so our next step, step three is to change into the newly cloned directory. So that means we want to change directories into this Geophysical Foundation model. So that's what we saw when we listed out everything that was in there, was that we had that Geophysical Foundation Model directory. So we want to change into that thing. So we'll type in that command. We'll say cd Geophysical Foundation Model, and I'll just start off. I'm a very lazy person. I like just typing out a couple of words, and then if I hit tab, it'll just auto-complete it for me. So I typed in cd geo, hit tab, it auto-completed the rest of it for me. And so what we're going to do is we're going to change directories into the Geophysical Foundation Model directory. Okay, so you can see how it changed from webinar being my primary directory here to now it lists Geophysical Foundation Model as my current directory. And again, we can enter ls and hit enter to see what's in there. And look at this, we've got all of the things that we saw in the repository. So we've got that code of conduct, contributing, some other markdown documents, our README file itself, my requirements file, and then we got some other directories. We could poke around in here if we want. We could go into change directories into the GFM directory and then run ls and see what all is in here. And we've got some Python files, cool. Now we want to go back up to that Geophysical Foundation Model level directory because now we're in this GFM directory. So to go up a level, we'll just change directories and then just ... takes us back up a level. Cool. So we are now back in our main, our root directory here. And again, you can see we've got all of our things from our root directory. Let's go back over to our README here. All right, so step 3 is done. Step 4, create a new branch. All right, so in Git, it's a good practice to always create a new branch for your work. So what is that? So again, it's like making effectively like another copy. So think of it as like a second copy on your local machine where you can go break stuff. And if everything breaks and is totally messed up, you can always just go back to the original main branch, and you can kind of like abandon the broken branch or delete it or get rid of it or whatever. So it's always good practice to create a new branch for your work. It keeps your main code base clean and organized. And if you break stuff, you can always go back to where you started from when you know that it worked.
Yeah, also a key component if you're using tools like Cursor or something like that, because then you can revert to like a known stable state. So I just had to pipe in. I had to pipe in. Sorry, Jesse, get back to it. But
No.
but branching and
Yeah.
using Git to get good commits is incredibly powerful for not having to do hours of rework.
In this case, it says create a new branch using this following command, which is just git checkout. So we're going to check out a new branch, which is this B flag here, and then feature, you can call it whatever you want. You don't have to say feature my feature. You can name your branch kind of whatever you want. I like descriptive things, so that way I can look at a branch and say, what was I doing on this, and not have to dive in too deep. So we'll go ahead and copy this. We'll paste that in here. So we've got checkout branch, and we're just going to call this tutorial. And then if I run this command, it's going to tell me, okay, I've switched to a new branch called tutorial. Okay, cool. I know a lot of you are probably thinking, okay, that's great. How do we see what all branches are there? I know I'd like to look and see, so I can say git branch, run that command without anything else, and it'll show us that I have 2 branches. So I have a main branch and a tutorial branch. And this little asterisk and color on this tutorial means that that's the branch that I'm on. Okay, cool. Step 4 is done. I want to call this step 4.2. Says, all right, now you're working on a separate branch and can make changes without affecting the main code base. The next section of our README just kind of talks a little bit about the directory structure of the Geophysical Foundation Model repository. So this directory called GFM that we saw in the terminal contains some of the model architecture, source images, has some of the images that we use in this README file. This tutorial directory, this is what we're after. This is that Jupyter Notebook that we're going to run through to show you how to get started with the model. This readme.markdown is this file that you're reading right now. License has some, the open source license file. And then this requirements.txt has dependencies for the model. This is kind of the overall directory structure, and this kind of orients you to like, what all's in there without having to dig too deep. So that's just kind of nice to keep in mind that this is really kind of this GFM section and this tutorial section are what we're after for this webinar. Okay, so let's jump into running the model. So this is where we say, okay, I'm going to skip this part of make sure you have Python 3.10 installed on your system. This is a kind of a whole process in and of itself. But once you've gotten to that point, you have Python 3.10. This is, if you're not at that point and you're watching this on the platform, feel free to pause it, get it up installed, get 3.10 installed, up and running, or anything newer than 3.10, and then when you're ready, hit play and get started. So let's start with, we're going to create a virtual environment. In this case, I'm going to use Conda to create a virtual environment. And you can use any virtual environment manager you want. I use Conda because it tends to be the easiest path for people that are just getting started. If you want to use env or whatever you want to use, if you're more comfortable with something else, by all means, have at it. This is just a quick and easy getting started guide. So for those of you that don't know what a virtual environment is, think of it as like, we made all these copies of our code so far. So we forked our repository to our own GitHub, and then we cloned it. So we got it onto our local machine, and then we made a new branch. So far we're kind of at like 3 different copies of our code. So what a virtual environment does is think of it as like, we're running a very specific, think of it as like Liam Neeson, like we're running a very specific set of code on a very specific set of dependencies. And so a virtual environment just makes sure that you don't have conflicting code dependencies. So if something requires like, as Python 3.9, you're not going to be able to run on that. So virtual environment really helps containerize your code a little bit more. It's a good, fast, and easy workaround. So what we're going to do is we're going to use Conda, and we are going to create a new virtual environment named Geophysics, and it's going to be based off of Python 3.10. And then to kind of avoid screen share whiplash back and forth from the terminal, I'll just walk through this now, and then we'll just do all these commands kind of in a row. So once we've created our virtual environment here, we're going to activate it. So it's a Conda environment. So to activate it, we're going to call Conda activate and then geophysics, because that's the name of our virtual environment. And then we're going to install all of our dependencies we need. We'll just run pip install. And then this is where that requirements.txt file comes in. These are all our dependencies that we need to get up and running for the tutorial and to run the model. So after that, we will start Jupyter Lab. This is to run our notebook, just so we can get that visual way to run our tutorial. You don't have to do this if you want to run just any general Python scripts with the model, but this will be to start up a Jupyter server and go through things kind of visually. So quick recap. We're going to create a virtual environment. Once it's installed, we're going to activate it. We're going to install our requirements. And then we're going to start a Jupyter server so we can have that interactive notebook type environment. So we want to Conda create a new environment named Geophysics. It's based on Python 3.10. So if I run that, it's going to effectively reach out and look for all of our different packages that go with Python 3.10 and says, okay, it's going to install all of these Python packages that go along with Python 3.10. We're going to say yes and run that. And it's going to download things and extract things. So it's going to take a hot minute or two. But generally, this is fairly fast. We're not downloading any super huge packages or super huge files, so pretty quick. Now, as I mentioned, it said, okay, to activate this environment, use conda activate and then the environment name. And then to deactivate an environment, use conda deactivate. Now, the key thing before I run conda activate geophysics is you'll see over on the left-hand side here, you'll see this base in parentheses. That tells me what environment I'm in using conda. So if I say conda activate geophysics, you'll see that it's now changed and says that I'm in the geophysics environment. Okay, cool. So we now have our geophysics environment active. So we're effectively isolating our Python install a little bit so that we can kind of break things, mess with things, and have some fun. And if anything breaks, we can just roll back and change our environment and try reinstalling. So the next thing is we want to, okay, we've got base Python. Let's add in some additional things that we need to run the model. So our additional packages. So remember that was pip install our requirements.txt. So I've copied that over and I'm just going to run that. And so what this will do is going to go through that requirements.txt file. And it's finding all these different packages that I cached earlier because it's so much nicer to not have to download things live. And so it's pulling all of these down from the local cache and installing them. And you can see some of the things that are in here. We've got Jupyter Lab, Notebook, Jupyter Server, Image.io, PyArrow, just kind of like a lot of really useful Python packages. So it's going to go ahead and install these. If you're interested, when it's taking a moment, you can come up here and look and see, some of the packages, some of the different versions that are in here that it's installing. And, if you're really interested, you can figure out which package versions it's going to use. And now we see that, okay, we've gotten back to our command line here. So cool. Everything installed. And so if we remember our last thing, we want to activate our Jupyter Lab server. So we'll go ahead and say Jupyter Lab. And so that's just saying, let's run Jupyter Lab. You can run Jupyter Notebook if you want. And so you can see that It's loading a whole bunch of stuff. And what you could do, you can either open it in a browser, or usually you can't see this, but over in my browser, it is already opened up and is running. But you can get a little bit of information here. You can see the kernel. And with that, we'll swap over to Jupyter Lab. And now you can see our Jupyter Lab server over here. And so think of this as like our kind of graphical representation of what we were looking at in the terminal. So we have our directories here, and then our markdown files, license file, README file, and our requirements file down here. And in this case, it already opened up with the webinar notebook open because I had it open earlier. And if we open up our tutorials directory here, you can see that this little green dot next to it says that it's running, it's live, and you can see it over here. Typically, if it's your first time starting up a Jupyter server, we'll say discard that, you'll see this. So this is the launcher. You can do like, you can start new notebooks, you can start a new Python console, you can actually run a terminal from inside of here. You can open up text files, markdown, Python files, kind of all kinds of fun stuff. Great place to get started. If you want to work on this in VS Code, you probably know what you're doing. You can directly open notebook files in VS Code. That's kind of a whole other direction. For this tutorial, we'll just use Jupyter Lab because it's fairly easy to get at. So with that, we'll open our notebook. So we've got our Geophysical Foundation Model. So that was November. For some reason, I thought it was in December when we talked about it. So this is the part that's a little bit more fun. We'll talk about getting things up and running, downloading things like model data, and then get our first bit of interpolation running. So this first entry in here says, make sure you've installed the requirements as outlined in the README. And so we've already done that, so we don't have to worry about that. So the first thing we need to do is we need to import some packages for data wrangling and inference. And then we also need to add the current path to the system path so we can import the GFM architecture later on. So we're pulling in kind of standard imports here, pandas, numpy, matplotlib, name a more iconic trio. I can't. And then we'll pull in scikit image, torch, OS, and system. So we'll go ahead and run that. You see this little asterisk over here shows that it's thinking, it's contemplating existence, finding its packages, getting ready to load them. And at some point it will have them loaded. All right, so it's changed from an asterisk to a 1, means it's run successfully. We have no complaints from our notebook, so that means that everything's hunky-dory. Let's move forward. We've done our imports, and we're going to add this Geophysical Foundation Model directory to the system path so we can use that later on. That one runs real fast. Okay, so this is where we start talking about Hugging Face. And we have the Geophysical Foundation Model on Hugging Face. Think of Hugging Face as like, it's also a Git repository, but it's primarily for models. So the model weights, these really large files, go on Hugging Face. And so that's a place to interact with the model weights and additional documentation. So it's kind of serves, GitHub serves like the code purpose, and Hugging Face kind of serves the model weights purpose. So they're both Git repositories, but kind of holding different contents. So to get the model weights, so we have the code, we know what the architecture is. It was in our GitHub repository. It was way back up here. Remember, we went into our GFM directory and we opened this, or we saw these two Python files. So this is our architecture, it's this elastic fitme file. So we have the code and we have the architecture for our model here, but we need the weights to get it loaded. Otherwise, it'll just initialize with random weights, and that's like, it just kind of throws out random seismic layers and says, sure, here, this is the right answer. And it's like, no. So we need to get the model weights. So to do that, you do need a Hugging Face account. Clark has added the Hugging Face links in the chat. Sign up for an account and then request model access. So once you go to the Geophysical Foundation Model on Hugging Face, once you're on that, on the Geophysical Foundation Model Hugging Face page, this is what you'll see. And so you'll have model card files and then kind of some other things in here. So it'll tell you what the model is, you know, what it does, that sort of thing. When you click on files here, this shows us all of our model weights. So we have a safe tensors file and a .bin file. So these are our model weights. You can grab one or the other for it. So once you've requested model access, I'm going to swap back over to our notebook here. Once you've requested model access, this will no longer show up. It'll say, okay, you know, you've already traded an email for the model weights. Cool. Then you need to set up an access token. So this just means, think of it as a token to get access to anything on Hugging Face. So that way you can pull and push just like you would for any Git type repository. So you'll set up an access token, and that's how we're going to use this Hugging Face Hub package. So once that's set up, we can run this next cell down below. So I'll run that, and I'll see this thing that pops up and says, hey, well, you need an access token. So I'll come over to Hugging Face, and I'm not going to show you guys my access tokens.
Just a quick jump in here, Jesse. So, well, this is a very advanced question for kind of the tutorial we're at, so that's why I held off. But this is not me speaking. I am the mouthpiece for Ashkan, our lead data scientist. So the question was, is there any best practice for fine-tuning the model for a new task? Which parts of the model should we freeze, hyperparameter settings to focus on, and any tips for custom data sets? Ashkan responded, you should freeze the early layers. Typically, the early layers of a pre-trained model capture general features like edges in an image. They're useful across different tasks. Freezing these layers can help retain the general knowledge. Fine-tune later layers. The later layers are more task-specific. Fine-tuning these layers allows the model to adapt to the new downstream task by learning more specific features. And then gradually unfreezing. Start by fine-tuning only the top layers and gradually unfreeze more layers if needed. This helps in stabilizing the training process. So I just wanted to get that into the recording as well. But Jesse, back to you.
Yeah, that's a great answer. Yeah, those later layers are kind of where the magic happens there. Let's see. Okay, let me paste in my, so I've got my token in here. I'll go ahead and log in and close that out. And so now this cell's run. I'm logged into Hugging Face. Cool. Now we can do some fun stuff like download things from Hugging Face. So we can download data sets. We can do snapshot downloads of our repositories. And that's what this next cell does is we say, okay, we've got our Patch the Planet data set. We want to download this file out of that data set. So we've got this Parquet file that we want to download. And we also want to download our Geophysical Foundation model from our model repository. So we'll start off with our model, or sorry, our data download. That's the easy part. So we'll get our data repository ID, the file that we want to download, and then our model repository. We're going to download that with our snapshot download. And we're going to go after our model type, and we're going to save it into a subdirectory called GFM weights because I like making sure that I know where it's going. So if we run this, you can see that we're fetching 6 files. We've got pretty much everything. Our data set's already downloaded, and then we're also downloading our model weights. As I mentioned, you know, these are kind of our heavy weights that we're picking up, and we're going to load into our model to make predictions. So while those are downloading, we could actually come back here come up to our root directory, and what we're going to see is we'll see our model weights in here. I think it's in tutorial. So there's our model, our GFM weights, and you can see that it just finished processing that 10 seconds ago. If I open that up, we've got our images, a config file, and then our weights. So we could either load the bin file or the safe tensors file. They're both there. And then we've got our README from the Hugging Face repository as well. So we've got all our files for our model. And then we've also got this data set folder here. You can see that we're saving it to our local directory. And if we open this, we've got a couple of levels of directories, and then boom, we've got our file named seismic cubes, RFC, full stack, 2023, bunch of numbers. So it's our Parquet file. So we've got that data set, we've got our weights, cool, sweet. Let's keep moving. So that's the hard part. It's just getting things onto your local machine to work with. So the next step in this tutorial is just data pre-processing. So we're going to define a couple of functions. Our first function is we've got to take that Parquet file and turn it into a NumPy array. So we pulled it down. We want to turn it into a NumPy array so we can do cool stuff with it. Notably, we want to mask it. So we're just going to blank out part of that image. And in this case, I'm just hard coding it. I'm just saying, let's just take this chunk out here of our array. We could change this to like 10 to 110 or whatever you want it to be. In this case, we're just going to hard code it because that's easy peasy. And then our next step is we need to actually convert our file into an array. And then we need to grab a seismic slice. So we're taking this 3D cube, we're going to take a vertical slice out of it, and then we're going to mask it. So you can kind of see this example down here. We'll go ahead and run this, and then we'll take a look at the output. So it's converting our file into a NumPy array, taking a vertical slice out of it, and then we're masking it. So you can see our seismic here. We've got seismic, and then we've got kind of this blank, funky gray color here. And then you can see our corresponding mask. So this is where we know we have data, where we don't have data. If we wanted to I don't know, we could change slices to 40. So we can grab different seismic slices if we want. We could come back up here. If we want to change our mask size, bigger. If we want to change our mask size, let's say we want to start it at line 70, make it a little bit smaller. We can change that. And you can see it's now a skinnier mask here on our data set. So these are things that you can play around with in this tutorial as you're working with it, learning about it. For this case, let's just go from 15 to 110, pretty good chunk that we're taking out of the side of this slice of seismic. So we've got our model downloaded. We've got our data downloaded. We've now transformed our data into an array. We've gone through, we've picked a vertical slice out of it. We've masked out some of it, so we've blanked it out. So if you think back to that November webinar that we had, we're basically playing Pictionary with this model. We're saying, okay, if I take a chunk out of it, fill in the blank, fill in these lines, connect them somehow. And that's what this model does in this base interpolation setting. It's just, it kind of connects the lines across here and thinks geologically what should be in this area that's missing. So to do that, we need to instantiate the model. So we need to create the model. We need to load the weights. And then we need to run our inference on our seismic slice. So the first thing is we're going to create an instance of our model. So that's what we're doing here. So we have to load it in. So we're going to import it from our local GFM folder. So in Python, we can do this. If you've got a CUDA-enabled device, that's what this next line does. Uses NVIDIA GPU if you've got it. If not, oh well, it runs on CPU. We'll create a instance of our model from our architecture. And then we'll load it up with this next line. So this is where we're taking our weights and actually saying, okay, we know what our model looks like. Now here's what all the weights for all of our different parameters need to be. So here we're loading it up from pre-trained, setting it to float, and then we're sending it to, if you have CUDA, it's sending it to your CUDA device. Otherwise, in this case, we're just sending it to my local CPU. So when I run that, it'll take a minute because it's like a 1.5-ish gig model. So it'll take a couple seconds to get it, load it, and then it'll print out, okay, here's what the architecture looks like. It's always a good practice to just look through here and make sure the dimensions match. That's kind of one of the big things, is just making sure that everything lines up, that everything looks correct. You can look at the architecture here, and so we're good. Our model's loaded. We've got the weights. We've got our data set. We're missing that chunk. I think we're about ready to do some interpolation. So now we get to do kind of the fun part. And ultimately, it's all about kind of this data prep. So we need to resize our seismic slice. So our slice, mask, get it to the right shape that the model can take in. We need to get the number of visible patches in that slice. We're going to run inference. So that means we're going to say, okay, model fill in the blank. It'll fill in the blank. Then we'll combine our predictions and our visible portions. So we'll say, okay, we know what you're predicting. Let's actually see what it looks like. And then we'll visualize it. So that's what this last cell down here does in kind of a 5-step process. So we can take a look at it. So we're going to prepare our seismic slice, get it ready, prepare our mask, get it ready, calculate the number of visible patches. So remember, for vision transformers, we're just taking patches of images and effectively turning them into tokens. We're going to get our slice that we're missing that we want to interpolate, and then we'll actually go through, get our prediction for our masked area, and then combine them all together and get a nice output. So this was the old one. If we run this cell now, we can see it's going to take a second to run. And again, you can see it running over here on the left-hand side. 13, it's done. And so we can take a look at it and say, yeah, okay, so this is that section that it was filling in. Okay, cool. Like, got this water bottom really nice and filled in, and it kind of gets fuzzy out in the middle, but that's okay. I'd rather have it kind of uncertain about some of these areas rather than more certain. But you can see it does an okay job filling in kind of this large missing section on the side here. So that's kind of the first pass. So if you want to go through, work through, different sizes, different areas, you would come back up here to the mask and really, figure out what portion of the image do you want masked, how much of it do you want masked, do you want different masks. So this is where you can really play around with it, see how it works, see what it does, see what breaks it, see what it doesn't like to do. And really work through the model. You can grab other data sets. Remember, we have the entire Patch the Planet data sets on Hugging Face. I just grabbed a single volume. You can grab any volumes that are off there. You can grab real data. Have fun with it. See what you can do with it. With that, I will kind of tease a little bit some future things that we've worked on that we've got some cool results from. If you think back, we had the Every Layer Everywhere All at Once challenge. Oh gosh, that was 2023. Wow, it seems like a long time ago. This is the GFM after 19 epochs of training on the Every Layer Everywhere challenge of picking out horizons. And so this is the GFM just with a repurposed classification head doing horizon segmentation on this data set. So the bottom, this is what our ground truth, this is what it should be. And at the top, this is what it's predicting after only seeing it 19 rounds through the data set. So it learns pretty quick. And in future webinars, we'll be talking about kind of different segmentation heads, different other cool downstream uses that folks have been chatting about in the questions section. So with that, Clark, questions, comments, thoughts, concerns?
I have a question, and
Yes.
so right now, GFM is open source.
Yep.
What is the strategy, into the future? Will it always be open source? How is this going to work? Are there things that we're keeping proprietary? If you can give a little explanation to that.
Yeah, good question. So we've got kind of two tracks for our Geophysical Foundation model. We've got one version that is going to continue to be open source. It's in the process of seeing a whole bunch of data. So it'll be a great pre-trained model for folks to work on. So we've got that version. Then we also have a proprietary kind of behind the scenes internal version that we're working on. And then, in the future, additional architectures, additional data sets. So we'll have some cool versions that we'll have seen. Think of it like you've got a whole bunch of geologists that have all seen different basins, different rocks. So there will be different versions that are open and different versions that are closed. But to encourage people to keep working in this space, we'll have as many open as we possibly can.
A follow-on question while we wait for this poll, and I'll share the results now. But upcoming data science challenges. We got anything running? Anything that's coming up that the audience should know about?
Yeah. So the first plug is for our core values challenge. It is closing, I want to say in like 3 weeks, 4 weeks, something like that. So mid-February, and then stay tuned. This afternoon, we're going to be putting out our teaser for our next upcoming challenge, focused on power systems. It's called Dynamic Rhythms, and it will be launching that in early February. So stay tuned for that. That one's going to be really cool. It's going to be some really nice spatial temporal data sets on that one. So stay tuned.
And as a follow-on, as the webinar guy, we're going to continue doing a launch series for each challenge that comes out, where we'll walk through some of the starter notebook, or maybe demonstrate a new technique that you might use during the challenge. And the goal is to bring our community along and kind of upskill people as we go. Jesse, maybe you could give us a quick story. I know we have some community members. You don't have to use their names, but historically, like where they started, where they ended up. I was really inspired by that the other day.
Yeah, great question. So there's been some folks that it's been really cool to watch their progression from, they landed on the platform and just started, I don't want to say hanging out with us, but like, competing in challenges and participating. And in the span of, a year and a half, they went from like kind of learning how it works to, they were in the running for some of some of our big payout challenges. They got picked up for one of our data science projects. So it was really cool to watch them go from like, getting started and being so close to like winning something to being, a great community member.
Yeah, hired on as a consultant. And the
Yeah.
the funny thing is like the again, I won't use their name, but was their email address actually has like learns to code in it. And so really to show the kind of progress you can make in a short period of time, with a good community and support network. And just came in from Vishnu. What kind of seismic data has been used in the pre-training, onshore, offshore, any particular geography?
Yeah. So the GFM's seen 450 seismic data sets. So those are all generated internally. They mimic offshore type environment. And then it's seen 50 real data sets, and those were all offshore as well from, I think it was a mix of, I think it was primarily Australian open data. So it's seen those, and in the near future, it's going to be seeing pretty much everything. So stay tuned for that in the coming months to get released.
Wild. Uh, there's also a question, do we have a Discord? At this point, we do not, but we do have Discourse. So you can join our platform. I'll make sure I put the URL in the chat right now if you're not already a member. And if you go into any of the data science challenges, there's a specific Discourse there, and it's monitored by our team. We usually respond within 24 hours, except for the weekends. So.
Yeah, yeah. I wish we had a Discord, but definitely the forum. We've got one specifically for Geophysical Foundation Model for questions there. If you want to ask questions on Hugging Face, it's all fair.
And another question came in, maybe a little problem with the GFM when setting up the architecture using the segmentation setting, we can't load up the pre-trained weight. One workaround right now is to load up the weight and then put the segmentation head afterwards. So
Yeah,
probably something worth again going to the forums, talking about on the forums. We can learn more if it's a bug or help you if it's not. So.
yeah, yeah, definitely. And as you know, as we get things trained up and additional things for segmentation released, we're happy to chat about that as well.
Really appreciate everyone's time today. Thank you very much for sharing it with us, and we look forward to seeing you on future webinars and participating in future challenges.